Hello everyone, welcome to this session. So in this session, we will go deeper into the model training in the machine learning procedure that I have said in the last week, right? So let's review the supervised learning flow first. So first we have the features and we have labels, we have the input data, so we call them training data, right? Then we use them to train a model. After the training, a machine learning model is obtained. And this model, we can input the test data to find out the prediction, right? So now the central issue is that what happens in the training, right? So before answering these questions, we first need to make clear two fundamental concepts: the hyperparameters and the model parameters. So what are they? So hyperparameters are the preset parameters. So these values are used to control the learning. So for example, in Kn, I choose K to 3 and 5. These are the hyperparameter K, right? And hyperparameters, they are set manually often, and they must be set before the training, right? So model parameters is rather different. These are the internal configuration variables of the model. So these models are estimated from the training data. So for example, the coefficients A and intersection B of the linear regression. So these are learned from the data, right? So the model parameters are the training outcome. So the hyperparameters set before training, model parameters, the training outcome. These are the key difference, right? So we are not optimizing hyperparameters. Well, that is preset. So then before start the training, we first need to understand one concept. We call it a loss function. So loss function is used to evaluate the difference between the actual output and the predicted output of a machine learning model, right? So this is highly related to the prediction error, right? So we call the function value y of the loss function, we call it loss. So we want to minimize it, right? The smaller the better. There are various kinds of loss functions. So for example, the mean squared error, this is for regression, right? And there's also mean absolute error, this is also for regression. And we have the categorical cross entropy, this is called for classification, right? And we have many more of the loss functions. So with a loss function that we can start the model training. So model training is doing what? So we are doing optimization in model training. The objective function of model training is a loss function. And the design variables are the what? Are the model parameters. So the goal is to find the optimal model parameter values that is for the model, right? So to train a model, we first need to define a loss function. Then we will minimize this loss function and we will obtain the optimal model parameters. So we can say we train a model, this is equivalent to we are minimizing the loss function. So we are doing the same thing, right? So what really happens in model training is optimization, right? So for the optimization techniques, we will introduce in the later sessions. And in this session, we will talk about the 3 example loss functions. The first one is MSE, mean squared error. So we can see the formula is here, and N is the number of training samples, and Yi is an actual value, and Yi with a hat is a predicted value. We find the difference of them, and we square them, and we get the average of them. So this is a mean squared error, MSE. So these functions have some characteristics. So first of all, this function is convex. So convex means what? As we can see in the second course of this specialization, convex means that only one optimal, right? And it's also differentiable. Differentiable, if you don't really know differentiable, we can just understand it's easy to optimize, right? And MSE is not robust to outliers. This is its drawback. So what are outliers? So we can see outliers are data points that are noticeably different from the other data. So let's see these two figures. So in these two figures, these are the data, and there's a point here. So we can see for these data, roughly they follow a linear relation in this direction, but this one is too far away from that, right? And for this set of data, all are clustered here, and this one is too far from that. So often these kind of points are caused by mistakes. So we call them outliers, right? So mean squared error is not robust to outliers. So it means that outliers will seriously affect the result of using the MSE function. So why? First of all, if one sample is an outlier, we can see for this sample, if given this x, the predicted value should be here, right? But the real value is here. So this is very large compared to other data. So this one could be dominate the MSE loss function. And moreover, this is squared because there is a square here, right, in the formula. So this is a problem of MSE. And how to solve it? We will talk about it later, right? Another function, MAE, mean absolute error. So this is the formula, right? A is still the size, and yi is the actual value, yi hat, this is the predicted value. So this one is better than MSE considering outliers. The question is why, right? So this is for you, right? So remember there's not a square here, mean absolute error, right? However, this one also has its problem, and this one is not differentiable, makes it hard to optimize. So these two functions, MSE and MAE, these are for regression. For classification, we can see have some functions. First one, binary cross entropy. You have seen it before and even programmed it before in the first course of this specialization, the MATLAB part, right? So binary cross entropy means we have two categories, right? So either this or that. So the formula is here. So if there are more than two categories, we need to use a categorical cross entropy as a loss function. So we can see the formula is here, right? So you can program it yourself and see in MATLAB how to call it, right? So these entropy functions are differentiable. It's easier to optimize, but however, it has some local optima. So then the question is that how to solve that and in the efficient manner of the optimization, right? So we will discuss it in the later sessions. One last note is that training is optimizing a loss function. This doesn't apply to all the machine learning techniques. So for example, the KNN we just introduced doesn't follow this process, right? So, but however, this applies to many or even most machine learning techniques. Okay, thank you very much. That's all for this session. Bye-bye.